PCF with non-uniform honeycomb. He is also the author of book named Wireless Communication and published books, chapters, and edited so many books. He has completed funding projects from AICTE and UGC of worth 22 lakhs. He guided 24 PG and 19 PhD students who completed their thesis under his supervision. He conducted 18 e-learning courses for PG and PhD students. He attended 23 events like conferences, seminars, workshops, training programs as resource person, and also organized 4 conferences and 5 workshops. He participated in 9 extinction activities. And there are much more to speak about this, sir. And thank you for giving me this opportunity, sir. Now I hand over the session to Nakkeeran, sir. Sir, please.
Thank you, madam. Thank you for the nice intro.
Thank you, sir.
Okay. Can I, yeah, good afternoon to all, first of all. Can I share my PPT, therefore I can take
yes,
off?
sir. I made you presenter, sir. You can share your screen. You can enable your camera also, sir.
Okay.
Thank you, sir.
I think you could see my slide.
Yes, sir. Yes, sir.
Yes.
Yes, sir. It's visible, sir.
Okay, just a few moments before we get into the slides. Thank you very much for the intro which you people made. At the outset, I must record my sincere gratitude to VVIT organizing team, particularly Professor Enamal Sai Haq, for having given this opportunity to share some thoughts about the latest trend in wireless communication, but in general, particularly in wireless sensor networks. With this small brief note, let me get into the presentation mode. I am going for slideshow. I think you could able to see my slide. Let me switch off my video because I am not in a position to see anything. My bandwidth constraint is also there. Yeah. Is it okay now?
Yes, sir. It is okay, sir.
Okay.
Okay.
So the
Yes,
topic
sir.
which,
Okay.
oh, thank you. The topic which I am going to discuss for another 120 minutes, too high. Rather, if I say 2 hours, it seems to be simple. 2 hours, we are going to discuss this topic, artificial intelligence in wireless sensor networks. With respect to, am I audible clearly?
Yes, sir. Voice is clear.
Yes, sir.
Sir.
Voice
It's
is
clear.
Okay.
Yes, sir.
Okay, thank you. Artificial intelligence in wireless sensor networks with respect to trends, challenges, and future directions. Let me put my view first. This is going to be the schedule of the presentation. We will be starting with the objective of the presentation, sources of the content, some preamble to make you to make you people to receive what I am going to talk about, the core concept. So the preamble is kept before the core concept. Then finally, the presentation will be ending with the conclusion and references. Something like this, don't worry. I'm going to take 40% of slides, around 90 slides are there. 40% of slides, these areas are going to be covered. Then major percentage I assign to the core concept, then very least percentage to the conclusion and references, but that is also equally important. Though the quantity is less, the concept which is buried within that is huge. But however, let me take that also into consideration while completing this presentation. Okay. So this is what my schedule. There are 90 slides approximately, maybe one or two I may add while writing some scripts. Therefore, I am not in a position to put the final number of slides. Okay. What is the objective of this presentation? The objective is very simple, imparting some insights on the chosen topic. Chosen topic already I told. So I will try to impart some insights over the topic to you, on the topic to you. In the process, not to turn the unturned stones, rather I am going to turn the turned stones again, that I am going to do for completeness. But best I will try to make you to understand the principles involved in this process. Let me try. Let me start with this gratitude note. Yeah, the first and foremost, I must again record the sincere gratitude to the Vasireddy Venkatari Institute of Technology, in short VVIT, Gundu, particularly Professor Enamal Haq Saik and his team for considering my candidature for this presentation and extending invitation and sitting at this stage now. All the things are possible but for Professor Enamal Haq. And this exercise made me to learn a new concept. But while learning, I come to know that it is not new, it is already known to me, but the different dimension of the concept I could able to understand in the process of preparing this talk. Thank you very much, all the people concerned. Then I must extend my gratitude to the International Telecommunication Union, third generation project partners, Department of Telecommunication, Government of India, Keysight, some websites while browsing that content, thanks to them, then many references. Out of many, I could able to appreciate these two things. The right side, what you could see, the review article, integration of artificial intelligence with the sensor networks, trends, challenges, and future direction. This is the paper given by your organizer to help me. But I could able to get the other one from IEEE Access. This is also basically a review article talking about the topic of our concern. So at this point in time, I would like to extend a sincere gratitude to all these people for helping me to learn. And in the process of learning, I am also making others to learn. That is making me to get joy out of this process. While preparing, I said no, many papers I come across. This is yet another paper. If you see the bottom, you could see a business management dynamics authored by Anthony Liu. He is relating a very beautiful different entities of our day-to-day activities with respect to the technical or professional domain. If you look at that, he called as DIKIW, nothing but data, information, knowledge, intelligence, wisdom. Actually, in the earlier version, this is a 2013 issue. Prior to that, intelligence was not added. He added the intelligence and made one paper and published in this business management dynamics. Of course, this is a finance oriented or management oriented journal. Nothing wrong in taking a good things from anywhere. So data leads to information, information leads to knowledge, then intelligence, wisdom. But wisdom is unidirectional. It is not bidirectional. We could able to harvest knowledge from the intelligence also by conceptualizing and constructing them. And we could able to take information out of knowledge by externalizing. If you internalize information, it becomes knowledge. Then the other one is the data. Suppose if we want to get some more insight, data are recorded, symbols might be captured or stored some places, and signal readings, they represent data. Then when it comes to information, is a message that contains relevant meaning, implication, or input for decision making or performing action. I think any clarification or may I request the authorities to mute the mic if it is not required, otherwise.
Yes, sir. I
Thank you.
muted it, sir. Sorry, sir.
Yeah, thank you. When it comes to knowledge, from the information, it is gaining the knowledge. Knowledge is the cognition of the individual concerned or the system. Now it is not a personal, it is beyond the human. So we could say cognitive system. Our recognition, it knows what is what. Capacity to act, how do I solve this problem? How do I attack this query? Understanding why. All these things resides are is contained within the mind or brain. Then when it comes to intelligence, it requires the ability to sense the environment, to make decisions and control actions by itself without any help from the adjacent systems, including the human system. Wisdom, we can say it is some kind of a perception gained over the life experience. Life experience, I say it is applicable for the human system as well as the non-human system. Non-human system also can have a wisdom. That is what our technological developments are marching towards. So what perception we gain over the experience, life experience, that comes to our mind as a wisdom. Then what necessitates the artificial intelligence? Dynamic environments. Yes. That is owing to the presence of heterogeneity, diversity, and the different aspect of heterogeneous and diversity is making us to have a dynamic environment to cope up with the developing technologies. Too many things are coming up, that too particularly in communication or computation, this domain, circuit branch domain, too many things are coming up. So we have to cope up. Deeper analysis and more insights are required. I want to know the nuances of the system in all aspects. How do I understand? I don't know how to exploit my brain, or how to explore also, I don't know. But I need some assistance to understand the other system, third system, with respect to all nuances. So I need some kind of assistance with that much smartness. Finally, flexibility. Yes, if I want to learn, I should. If I want to get, I should. If I don't want, I should. So that kind of flexibility is required. Please remember, broadly I am telling, but particularly when you take a mission as a system, flexibility, it means a lot. Flexibility in it is not only making us to feel comfort and conducive, it results with efficient, effective, optimal resources cost. That is what everybody is looking at. I want to get, or I want to harvest effective output. Efficiently it should provide, and they must work optimally. So all these factors are necessitating the implementation of intelligence into the non-intelligent system. Therefore, we call it as artificial intelligence. What is artificial intelligence? It is the simulation of human intelligence process by machines, especially with the computer. You put it into the computer, then it becomes artificial intelligence system. What are its applications? Enormous, specifically to coin export system, natural language processing, speech recognition, machine vision. Some machine learning is also subset of artificial intelligence. Deep learning, of course, again subset of machine learning. Together we can call data science. They also help us to predict some kind of system responses. Apart from that, we can extend it to automation, robotics, planning, optimization, etc. For example, or to specify some of them. How the intelligence machine is evolved. Please remember, this is purely evolution. Darwin said, human system evolved from monkeys. Yes. Darwin theorem is telling, of course, there are different schools of thoughts. I'm not going to get into that conflict, but natural acceptance is there. Majority population accepted the Darwin's theorem. So based on that, it is an evolution. Yes. In technology also, evolution is possible. Evolution is a natural instinct of nature. Nobody can stop, nobody can avoid or exclude. It is inclusive process. Whether you like it or not, it is there in your system. It is there in your life. So we started with the physical system. What is physical system? Being all teachers, we know. It could be a working model, or it could be a conceptual idea, or it could be a combination of both. That we can call a system model, physical system. Then gradually we go into automatic machine. That automatic machine we transform from machine to automatic by programming the system. Here comes. Please remember, when I program, I have to have provision to program, both in terms of hardware and software. Just you recall the early mnemonics will help to automate, and application specific integrated circuits based boards can be used for this kind of things. Then third stage, I can say smart machine. The programmable system we transform into reconfigurable one, as and when or what way I want, where I want, how I want, that kind of reconfigurable with required facilities, with required options. That is possible if we again have both software and hardware. But now hardware, I have to have flexibility in the hardware. This is what the flexibility I talked about in the previous slide. ASCII, you know, limitations are there. So we go for FPGA based hardware boards. Mnemonics are machine level language, we have limitation. So we go for high level language, Python, C++, R, etc., etc. So we could able to get some kind of smart machine version that can be tuned as per our desire. But here in the second stage, automatic machine, we have some issues, but that is sorted out here. The third and the fourth one, that is what we are talking about. Our concern is intelligence mission. We are not satisfied with artificial, we are not satisfied with reconfigurable, but it has to think by itself. What I think, it should smell and understand, and accordingly it should obey. Without my input, it should produce the response intelligently. Yes, AI-based system is possible that transform this smart mission to intelligent missions. But I can say that is nothing but on par with the human system, almost, except some features. Even emotion also people are trying to inculcate in the intelligent systems. Then what we are, the natural intelligence. What they are, artificial intelligence. What is the gap? Nobody knows. We can classify by putting the table, but please mind it. This is the advantage of our technological revolution. At the same time, the other side of the coin is this is the great and grave drawback of our technological evolution. This is my personal view that I will discuss maybe at the end of the session. This I was discussing about my FDP program with Professor Enamal while we were checking the connectivity for this session. I am attending on FDP 5G technology. This is taken from that program. 1G to 5G evolution. You see that 1980s, 2G, 3G. Accounting the time constraint, I skip, but the other factors are there, you can understand. The highlights of this slide is these 3 points. Mobile technology is continuously evolving. If you look at every 10 years, 80s, 90s, 2010, 20, every 10-year, next generation of mobile technology has evolved. 2020 is passed out. Now we are sitting on 2024. 6 more years are there. Yes, 6G. People are talking about our specifications are being framed for 6G. That I will also discuss in the next slide. Every next generation has brought over 10x, 10 times increase capability. Let it be in terms of your data rate, or latency, or mobility, or densification, energy efficiency. In all aspects, in general, capability 10 times more than what it was in the previous generation. This is the takeaway message out of this slide. The other details, if time permits, we will discuss in some other context. Of course, what for this voice service, the digital, all these things. Who are the authorities to decide this kind of evolution, all these things? Across the world, many countries, around 130 plus countries join together and they form ITU Council, International Telecommunications Union. They are the policy maker for entire globe. They only propose, yes, we can go for 2G, 3G, 4G, 5G. Yeah, 6G can be thought about it, or something with respect to telecommunication. Therefore, ITU. They are the authority. They are the ultimate authority to take the policy issues based on the day-to-day, based on the need of the society and dynamism of the other factors. Then what next? 3GPP. They are the specification standard making people. Of course, started in the year 1998, and technical specification for the policies what the ITU makes. These people provide technical specifications and technical reports. This is what, for example, 5G data rate, user plane is this much, control plane is this much, latency this much, say 1 milliseconds or less than 1 milliseconds. Population covered per square unit area is 10 lakhs devices under that. Something, all that specification is being formulated by this 3GP, third generation project partner. Of course, this is the icon, usage of icon is very, they are very particular. We cannot use this icon. This is also 3GPP icon, but meant for LTE, LTE Advanced and LTE Pro. This is for 4G. For 5G, they recommend this. 5G, then 5G Advanced. 5G Advanced, 19 release is about to come. 18 release is about to come. Who are all the people helping these two bodies? SDOs, Standards Development Organizations. They do this kind of standards. We are proud to say that India is one among the 7 countries. ETSI, it is from Europe and rest of the world, they follow this standard. USA is following ATIS, and Japan is following too. TTC is their own, and ARB is from America. They take and follow. South Korea follows the TTA, Telecommunication Technology Association. China, CCSA. India, TSDSI, Telecommunications Standards Development Society. They, of course, this sometimes they join with the TEC, Telecommunication Engineering Commission. TEC, TSDISI is there in union with ITU and 3GPP. Apart from that, TEC is also there from India to represent that. But the other things are only regulating. This body is involving in standardizing the particular specification. This is the release which I was talking. 14 is the transition from 4G to 5G, and here that 5G things started, EMBB, and here URLLC started. Release 16 in the year 2020. This is release 17 in the year 2022. This is what I was talking about, 18 5G advanced planned. It is in the progress. 19 is planned. 19 is going to talk about fully 6G. What made me to put this slide before you is that if you look at this content of the release, of course, these are all the content they are going to complete within the period. With that idea only, the SDOs have formulated this and released. If you look at this advanced, which is in the progress, artificial intelligence and machine learning based radio from base station, in simple meaning, base station, UE to base station, that radio link, no? That radio link they are going to, or wherever the radio link comes in the platform, they are going to use AI and ML based models. And that this organization, VVIT, has thought about it, and they are running this course. Really, I appreciate from my side. Yeah, need of the hours rather. Then this 3GPP, or wherever you go, ITU or 3GPP, and of course ISO, many, these are all very pertinent authorities or organizations with respect to telecommunication. Similar to this other domain across the globe, there are different standards. You might be knowing that. Within that 3GPP, so many technical specification groups, TSGs are there. TSG for RAN, TSG for core technology, TSG for SA standalone technology, something. In that RAN 1 radio layer, physical layer, if you look at ML, artificial intelligence, these things are going to be there in the physical layer. This is taken by the RAN 1, that is one of the TSG, one of the DSG that is coming here. RAN 1 lead is somewhere here. Yeah, here. Physical layer. You can see the TSG RAN. Under that, this is another subgroup. The RAN 1 radio layer 1 is going to concentrate on development of radio interface with the help of ML and AL. I am gradually I am making your mind to understand what is the need for learning the ML based concept, AI based concept for the communication technology. That I wanted to gradually make you to understand. These are all the standards across the world we decided. People have thought about it, and it is need of the hour to understand ourselves how to integrate these methods with the technology available, and therefore that is ready now to integrate with our radio communication. Please remember the 5G, whatever we talk about, this they are the carrier. Communication means one place to another place, it could able to take the information at very high data rate with less latency, with other factors, parameters, you know. They are the means of communication, but how, where, what, all the things we have to define very clearly. And in the process, these bodies are helping us to slowly integrate and imbibe the new techniques and technology coming into this arena. So it is our responsibility to understand and go in stream with them. What necessitates G, 6G. I just to make the other way, I wanted to put this. We can, which means we have space to add one more G or any number of G. 6G. What is it? It is too early to talk about 6G, but nothing wrong. What necessitates? The demand for wireless connectivity has grown exponentially over the last years. Am I audible?
Yes, sir. Audible, sir. It's clear. The voice is clear.
Okay, there is a power, what I can say, flickering here that made
no,
me
sir,
to have
voice is audible, sir. It's clear. It's
okay.
Continuing.
In case if it is not audible, or if we have any disconnection in the net, please inform me through the mobile. Yes, therefore, I can understand.
Yes.
Yeah,
Sir.
thank you.
Sure,
Thank you.
sir.
By 2030, in the year, there should be around 17 billion of mobile connected devices, with monthly data traffic in the order of 1,000 of exabytes, 10 power 18. Please try to understand million, billion, trillion. It goes that way. So I hope you know the quantum of the magnitude of the billion and the magnitude of the exabytes. That much data you have to handle. With 5G, whatever the specification, 5G yet to be deployed, it is in the process. Some places across the country they installed, but in India, it is in the process. Then with 5G, the network should support stringent requirements in terms of data rate of this much, latency of this much, connectivity, reliability, energy consumption. These things cannot be met by the 5G, what we are talking about here. What we are talking about here, it cannot be met. So therefore, people now, these people envisage that, and they make some policy. Future, we are going to have that much data, that much traffic. So we make policy. Let us make policy. These people again, they make standards and technical reports. and we people study. And we understand that this fellow is not sufficient. We have to go for 6G. Therefore, people are jumping into 6G, 5G to 6G. Please remember, already many countries have started to work on 6G, including India. About some 6, that there is a crack in that. Therefore, I am talking. If not visible to see this, let me. Yeah, these are all the key performance indicators of I can say 5G, 6G. The ash color, what you could see inner is 5G. The blue one is conservative, and brown one is ambitious parameters. Throughput, user plane latency, reliability, connectivity, density in the connection per square kilometer or meter per unit area, location precision, battery life, energy efficiency. If you look at all these things, very, very alarming figures, but that is what it is required to meet some kind of use cases. Use cases are unique, but what is required, a particular set of KPI for one use case need not to be there for other use case. They differ. I will tell you some use cases, therefore you can understand. To meet this kind of use case requirements, we have to have ecosystem. The standards making bodies are making rest of the world to make the ecosystem ready. Therefore, you can harvest the yield out of the use cases. That is the idea. So these things driving us to go for, okay, 1 minute. Yeah, 6G. If you look at, there are 4 dots in the bottom. Particularly 3, let me talk, then I will come back to the blue one, these 2. In addition to enhanced communication capabilities, what we have been doing so far over the year, over all generations of mobile communications, evolution of enhanced mobile broadband, EMBB and EMBB plus. That is the main objective. Data rate, more capacity I want to have. That's the idea. Evolution of ultra reliable low latency communications. Latency must be as low as possible. Here you see that 0.1 millisecond less than. Where do we need that? Unmanned car, unmanned airborne vehicle, or robo-based operation. Remotely you do. I want to control operation being done by the robot remotely as a doctor. So in these use cases, reliability is very important along with the low latency. So you have to have, when I say you cut that now, it should not cut after 2 minutes, or I mean 2 milliseconds, or even 2 seconds. Within prior to that, the moment I say, when I think I want to cut this now, and the robot must cut that now. That's the instances. Yeah, instances are also another requirement of some of the forthcoming releases. So URLC is the second one which I am talking about in the corner of this block. Third one, evolution of massive machine type communication, MMTC. This is what the new technology, IoT. So many variants of IoTs. So massive connectivity, that is making us to get into the densification. What do you mean by densification? The number of entities. Entity, I mean to say that it could be device, it could be computer, it could be mobile equipment, it could be anything. The number of entities per unit area is going to be more. Therefore, the density comes into picture. This is not important. All these things are there in the 5G. What is more important in the 6G and what is not there in the 5G is that the sensing and communication together. Wireless sensing along with the networked artificial intelligence are expected to play a critical roles in 6G and beyond to meet the demands of information communication technology after 2030. That is the foreseen thing, and which we are expecting. 2030 is not far away, within another 6 to 5 years, and it is a right time to start. Again, I appreciate these organizing people and you people, participants also. It is a correct time to take some kind of idea out of this course and you start doing something. Therefore, you are also contributing for the development of the globe. Please remember, those organization authority, I said, no, you can easily become a part of that system by becoming a member. You can easily become a member. Your institute can become a member. Matter of money, that is negotiable, or it can be managed with some other means. Jointly, you can collect and make institute to become member. Then you are free to assess anything. Your contribution will be recorded under your name. That's what. Something like a paper publication, patent publication, now standard publication. You can also become contributor of the standards. So this is what making me to talk about the wireless sensor. I immediately thought about it. Sensing is possible. No, you see that wirelessly I want to sense. I know only the RFID because I have been working on electromagnetic, and of course optical is also electromagnetic, including that electromagnetic. Therefore, I know how to do that kind of things remotely with the help of radios. But sensing alone is not enough. This side I know, that side also I know, communication I know. Interestingly, intelligence also I know. I had a degree, I have a degree in life science. So these three domains independently I know. But this is an opportunity to connect all these things. Sensing, intelligence, communication, that is the future. Sensing alone is not enough. You have to communicate. Communication alone is not enough. You have to sense and then communicate. But ecosystem is required. You have to develop the ecosystem. And you have to use the ecosystem for the particular use case or appropriate use case. And all use cases are not going to demand this kind of very high profile capacity. Accordingly, you have to slice them. Network slicing is also possible. Okay, now the other side, wireless sensor networks, WSN. When I go through that, I could able to get something IEEE 802.15. Yes, we had been working on IEEE 802.11 and 16, the WiMAX, all the other things. But I didn't get chance to work. But I know it is around 802.15. And Bluetooth low energy. This is 0.1. I mean 15.1, 15.2, something like that. This is one standard governed by IEEE. The other one, International Standard Organization. This is also International Electrotechnic Commission, IEC, International Electrotechnic Commission. Through this number, talking about the reference plane architecture of the wireless sensor network. If you take any network, you have service plane architecture and reference plane architecture. Service plane architecture is talking about what are the services you could able to have. Reference plane architecture is talking about what are the interfaces, how you could able to communicate within the system, intra system or inter block communication, references, air interface or some other interfaces. So with respect to that, the network we can view. So this standard is talking about reference architecture of WSN. Of course, Bluetooth low energy, otherwise Zigbee comes under that. Basically, this is infra structureless type of architecture, a part of ad hoc, all derivatives, you know. What is what? Accounting the time, just I am going fast here. WSN, you can say that this is the multiple energy efficient, cost efficient, autonomous, tiny sensor nodes. Some, of course, all these things are there, and different types of sensors you could be able to have: chemical, acoustic, thermal, optical, weather, pressure, depending upon the application and depending upon the requirement. And what these network sensor does, they collect the measurement to be measured, or the particular parameter what it should measure, it is measuring and communicating to the base station. Base station have some kind of base stations have some kind of higher capacity processing, and if it is required, it can transfer that to the other places through the core network or internet. You can analyze here also possible, but Paka or complete analysis is possible here. Storage, you can store it for future reference, or you can monitor, you can do other things, processing, mining, etc. All these things are possible. So this is basically a glimpse of wireless sensor network. What is the standard? What for this? I wanted to capture something: agriculture, fishery, or sea, or exploration, or even Arctic exploration. This is useful. Or moon exploration, this is useful. Or among the satellite, this is useful. Or you take anything, this is useful. Only thing, we have to scale it up. What are the challenges? Broadly, primarily, there are three challenges. Having gone through the literature, I understood. Coverage. How to monitor the network field effectively is the coverage. It is not spreading alone. It is not covering the area under the surveillance. How to monitor the network field effectively? How to monitor the sensors, interconnectivity effectively? The word effectively conveys effective meaning that you must understand, please. Deployment. Many methods are there. Many methods are there. Basically, deterministic type of deployment and random deployment. If you take forest, you cannot go and install, say, one point by point the sensor. No, use the drone or go make use of the helicopter to show the sensors. Randomly you can distribute, or deterministically you can distribute. In the case of agriculture, the sensor you can plan as per your design. So deployment is another very tedious. You have to, please remember, it is not only spreading the sensor to harvest the parameter. Whether the installed or spreaded sensor is going to work or not, how are you going to manage? Because there are, it is basically battery supported power system. Battery, there are, you can replace the battery, you can recharge the battery, you can't do anything, fix the battery. Neither charging nor recharge, I mean, replacement is possible. That is called a fixed battery system. Once the battery life is over, that system itself is over, you can use and throw. Replaceable, you can replace the battery. Rechargeable, you can recharge the battery and you can make use of those two systems. So deployment is another major concern, challenge. The third one is the localization. Localization, what I understand is that determining the physical coordinates. Suppose I take a rectangular coordinate system. Coordinates are X, Y, Z. What is the sensor with respect to that coordinate system? What point with respect to X, Y, Z I wanted to know. If I know the position of the system, then only I can do, then only I can control, then only I can understand that whether it is effectively doing it or not. Added to that, please remember the earlier or the very old version of WSN, all the things are very static. But now we are moving to the dynamic. The moment dynamics comes, mobility is default. The sensors which we spreaded, which we put over the system is not going to stay there in the place where it is dropped. It is going to move. Imagine the localization is going to be the very, very great task, Himalayan task. Physical coordinate of the sensor I want to know. Today I measured that I am at this place, say X, Y, Z, I can say 1, 2, 3. This is the coordinate of a particular sensor. After 1 hour, I don't know where this is going to be. The speed, it is not the velocity of the sensor. The speed of the sensor is going to be some kind of sizable number. Had it been velocity, localization is not an issue. It is a speed. Speed is a scalar quantity. Velocity is the vector quantity. You can understand the rest. Not only these. Dynamic, static became dynamic, added to that, these three, added to that dynamic, added to that, all these things are the concerns of any system designer of WSN. Security. That is more important. Data reliability, data aggregation, event scheduling, energy aware, or in general routing, clustering, fault detection. Here, that also we have to, like error control code, ERC or ECC, whatever we call. This here also fault detection is equally important. Otherwise, I cannot get any input from that sensor if it is not working. So the same thing is put into the other thing, latency, coverage, some security, all these things. And this again, the challenges with respect to, for example, sensor is there and the internet you are using user, vulnerability is possible. I hope you can understand what is the meaning of vulnerability, risk, all those things. And this, if we take any security measure, security services, and securities. These three are very, very important terminology with respect to security. Security measures, the things which are ready to not to tamper the system are called security measures. Suppose in our university security people, some guards, they will not allow unauthorized people into the campus. That is a security. Posting them is a security measure. Added to that, whoever comes into the university campus, they have to wear the ID card, or they have to produce the ID card the moment it is asked. If you don't produce, you will not be allowed. That you can also treat as a measure. Issuing the ID card to the stakeholder. This you can bring it into the service also, security service. These security measures, security service, and securities are required to uphold the security. Otherwise, it will lead to snooping, sinkhole, tampering, Sybil, clone, wormhole, spoofing. Why not simple virus, antivirus attack? Virus attack. We have antivirus, but that is not taking care of all viruses. So this is one illustration wherein you have vulnerabilities for many things. This is another localization, and you can treat this also for data aggregation or something like that. Localization and positioning of this sensor. And this is aggregation. Energy management. How do I manage? And the cluster head identification. Suppose I am the head, I lose my power. I cannot be the head. Someone I have to, not someone, the person, the sensor who has more power, I have to hand over. I have to identify and hand over before I die or before I become ordinary member. That is also responsibility, energy. And I should, this is only cluster head identification and transferring the function of the head. But energy management mainly talks about how to conserve the energy. When I am not, how to use energy effectively. That's the meaning. I should not send redundant data to the base station very frequently. Only the important data I should change in the measure, and I should send. All data I should not send. Thus we can able to manage the energy utilization. Thus it becomes energy management. In nutshell, I can say not only three and those listed, all these things are the challenges in WSN at a granular level. If you refer some more papers, still you may get more points to add to these challenges. Issue you can take, or vulnerability you can take, or the drawback, limitation, but I am transforming all things into challenge. Therefore, you have provision to say the challenges are your opportunities. When I talk about this energy management, it is an opportunity for research. Data aggregation, yes, it is not possible to aggregate, but that is my opportunity. I can take, I can transform, I can do the way in which I want. If not in one attempt, I can go to the next level, and my successor will follow that, and he will or she will take to the next level, next level. That way I can take this as an opportunity. So all these things are going to be opportunity. I'm not going to deal one by one, just to show so many challenges are there in WSN. I am showing that. What are next in AI for WSN particularly, and the taxonomy of artificial intelligence? If you look at okay. So the learning methods, fuzzy logic, hybrid of this meta heuristic, multi-agent system are some of the artificial intelligence techniques that those can be used for WSN. When it comes to 1 minute. This is machine learning. Also, as I told earlier, you can see that machine learning also subset of artificial intelligence. Of course, deep learning is again subset of ML and AI. If you look at the machine learning, you can see the decision tree, support vector mission, naive Bayes, nearest neighbor, k nearest neighbor, random forest, association rule. All these things are coming under the machine learning. And when we talk about this kind of CNN, RNN, AEs, RBMs, deep learning things, when you talk about particle swarm intelligence and colony optimization, stochastic diffusion search algorithm, artificial swarm intelligence, even bees, so many things are there. All of them will come in general swarm intelligence. All these things are called swarm intelligence. So, yeah. This is the taxonomy of your artificial intelligence in broad sense, particularly machine learning, swarm intelligence. You can say evolutionary or evolutionary concept. Yeah, evolutionary concept. From other living beings, we could able to take their behavior for optimization, or sometimes we use for what you call optimization is one area. Even detection, we use this kind of process. Decomposition, yes, decomposition, we can use that kind of algorithm. So this is again ML and AI. I can skip this slide by accounting the time. What are the main sources of my this concept? From the whatever I discussed is the only preamble type of things you can account. The main source, as I mentioned in the gratitude slide itself, these two papers are stemming me to get some kind of content for this presentation. Again, I thank Professor Enamal for that. Very nice paper this is, and this is additionally I got it from other place. This paper, if you look at, it provides an in-depth analysis of various recently proposed AI strategies over this period, 2010 to 2022, that have been applied to this particularly. This 71 paper they identified, useful algorithm they developed, they used 71 papers in this review paper. Useful other, more than 71 they referred, but I am talking about 71 useful paper I could see. When it comes to the right side, this one, integration of AI with WSN, 134 papers over the period of 2007 to 2023, just 1 year before or some 6 months before. How they adopted WSN, this concept, they nicely explained with the very, I can say these two papers are very holistic in approach and comprehensive in nature. They presented the benefits and drawbacks of different techniques employed in WSN. Finally, they also discussed further research opportunities that would enable scalable and cost-effective AI deployment in WSN. So you can note down this paper, otherwise I pass on this information. You can please understand the details of content if you go through the paper. You can very easily understand, nicely prepared papers, very easily you can understand. Please kindly go through if time permits. If you, those who are interested to pursue the further studies, postdoctorate, my suggestion is one of these papers or both. And back volumes also you please refer. I referred some many back volumes of these two papers, and therefore I could able to get some confidence. Clarity is the power. Okay, please check all those back volumes too. The literature, AI literature statistics, if you look at the coverage is the prime, one of the prime challenges, no? Out of 71 papers which I told, this dark blue, dark blue represents swarm intelligence. That algorithm, swarm intelligence algorithm, is used to provide solution for the coverage challenge. Like that, yellow 19, 13. This is also 19. This is something like your nature inspired. That swarm intelligence is nothing but nature inspired. And when it comes to deployment and localization together, 32% is swarm intelligence. So swarm intelligence is really intelligent enough to provide solution for the particular application. That is what I took it. So hybrid also providing sizable percent in this case. Here also hybrid. So this is a statistics over the different algorithm used on the literature. And this is the literature details. That is a statistics I told. This is a literature details. What I mean to say that what is the paradigm in particular ML or AI they used, what algorithm, which paper uses that, with what objective they started, what kind of simulation, whether they simulated or they deployed and in the real time and measured the, captured the data, and whether it is a centralized sensor network or distributed sensor network, whether it is static or dynamic, what are the performance metrics, you can say KPI, the key performance indicator they considered. So that is what it is given. It is not prepared by me. It is available in the paper itself. But if you go through them, I referred a couple of papers which are which I wanted to refer, but for understanding some concept. So those things are very interesting. We could able to get a beautiful idea, beautiful understanding. Understanding itself is a very satisfied feeling. Yes, I understood this concept clearly. That kind of feel I could able to get when I get into these back volumes of this review article. Like that, for many algorithm, it is listed. Just I showcase to you and you can understand what is what. It is not if time permits. I request please assign some time and you go through them, at least a couple of papers. The list continues for other heading. Literature details continues. Again, it is continuing. And when it comes to this, I hear the list is the other way. Particular concept is given. What paper is covering which attributes? Clustering, aggregation, energy harvesting, localization, event detection, MAC control. This is the protocol. Okay, which algorithm is being addressed to attribute this function? I mean, which paper is taking this algorithm and attributing this function? That is what this table is. For example, KNN algorithm is used for clustering by this paper, whereas for clustering this paper uses regression, whereas the routing this paper uses ANN. For the routing, this paper uses SVM. That kind of why not something? This gap is there. Can I use regression for routing? That question comes. That is an interesting understanding, no? Interesting avenue. Why not KNN for routing? Or why not ANN for clustering? that question comes. So when this is what this is something like the presentation, the way in which it is presented, it makes me to get into that. Why not energy harvesting this regression? Why not KNN for this? That kind of thoughts comes to my mind. Please, you go through that, you can enjoy really. And interestingly, you can see that some function, many people attempted. You see that clustering aggregation, many people attempted, but with a different, that also it is there with a different form of tabulation. I will show you. When it comes to that place, I will show you that. Please, yeah, it is there in the part of the slide. I will show you that. Okay. Just let me take 2 minutes break to have some water. Meantime, this pause time is to think what I told. If you have any question, I come to this conversation platform. If you have any question, please feel free to raise. Any queries from anybody?
Yes, sir. Good afternoon, sir.
Yeah, good afternoon. I don't know who is talking.
Sir, yes, sir. I'm Bhanamurthy from VVIT.
Okay.
Sir, actually, he is our head of the department.
Head of the department. Yeah, please. Nice to hear your voice, sir. I have seen your writing style, but this is occasion to hear your verbatim. Yeah, please go ahead, sir.
Thank you so much. Sir, I have a small question, sir. Thank you so much for the insightful expert talk, sir, until now. Sir, some applications it may require real-time analysis on the sensor node. While some other applications, they may they can tolerate some delay and they can transmit the data for processing elsewhere. So, what is the choice of AI models? Can you just give a idea, sir, for real-time analysis or?
Yeah, definitely, sir. That area to be covered, sir. That area
Okay,
to be
okay.
covered.
Okay.
And just I am preparing the people, I am preparing my mindset to accept the new concept which are going to be discussed.
Okay, sir. Okay, sir. Okay, sir.
Yeah, that is a very beautiful question. Real time, when I go for implementation, real time hardware implementation, I collect some data. I wanted to transfer those data to some other system beyond the base station, yeah, processing station, and how to tackle the latency incurred. What model is useful?
Right.
That we will be. Yeah, I will give choice to you. You can select options from your side.
Sure. Okay, sir. Thank you so much, sir. Thank you.
Sir, one more question from one of the participants. So
Yeah, please.
what are the challenges with respect to security in communication when we adapt AI in communication?
What are the challenges that actually that is there in my slide as a challenge itself? We have to explore together. But
Yes.
as on date, there is no standard mechanism is available to my knowledge, which I explored over the papers. And that security itself is the challenge when we deploy AI as a tool for improvement, improving the performance with respect to WSN network. That itself is one of the challenges that I will discuss as a challenge. But honestly speaking, that I don't have any specific solution for that security problem. Okay. With your permission, if there is there any other clarification to be made? Actually, I have not clarified anything. 2 questions they posed, 2 questions I postponed by telling that future slides will cover. So is there any clarification from the content covered so far? If so, I can enjoy. You can also get some more information. Otherwise, I will proceed. Okay, thank you. So what are the leverage of ML with respect to WSN platform? All these things are great. Okay, the creation of learning process and computer models that offer remedies for the knowledge acquisition problem improves the performance of the developed system. The sentence is very compound. Sorry for that. I simply put it, it improves the performance of the WSN. What is that? Very simple, you take. The WSN is WSN otherwise. If you adopt ML, whose performance is more, that's what. We are not adding anything to the system. That's the beauty of ML, the leverage of ML here. Added to that, another one, computational methods plays a pivotal role in augmenting machine performance by not only detecting but also describing patterns and consistencies within the training data. It helps us to understand the pattern, how consistent the data while training the network, while training the algorithm. That also the ML is providing something like self-cooking. This is self-cooking, I can say. This is self-cooking. This I can skip accounting. I will cover the next coming slides. Leverage of AI in WSN also. This also I can cover the next. Okay, this is the point I wanted to talk. machine learning techniques. I told as a taxonomy of machine learning or taxonomy of AI, under that machine learning I listed. And those things broadly you can classify into only 3, but I have given 4. Supervised learning, unsupervised learning, reinforcement learning. These 3 are there. But semi-supervised is added to that. Broadly, you can say 3. This is added 4. Fourth one. Okay, what is supervised? We will see in detail in the subsequent slide. Before that, what is your machine learning? This is a schematic representation given the right side of the slide. So you give something training data to the model, algorithm and model, and train the algorithm model and give new input. This could be able to predict. If the prediction accuracy is acceptable, you can say success, Eureka. Otherwise, you again train the algorithm, train the model, and give the new data. This is a iterative process until you get success, accuracy. When I should something like I teach some baby, A for apple, B for apple, or I show the apple and say this is apple, this is apple, this is bus. When I ask her another situation by showing that another new bus, what is that? If she says it is bus, I'm successful. Otherwise, I have to teach her with the other type of geometry, other mechanism. That's what the professor is asking. What algorithm is best? If my teaching is not good, I have to change the mode of teaching and make her to understand. It doesn't mean that her cognition is low. She has good cognition. He has good knowledge, are intelligent enough to understand what I am teaching. But my method is not. That is what here I remember one quote made by a famous person. In a communication process, if the communication is failed, it is not the mistake of the receiver, it is the mistake of transmitter. Rather here, I speak, you receive. If you don't understand what I speak, it is not your mistake, it is my mistake. I cannot communicate. I have not communicated properly. That's my mistake. It is not your mistake. So I have to make your mind to receive what I am going to talk. Then I should talk. There is another statistical study says that in the presentation period, if 1 hour is there in the classroom teaching, 60 minutes is there, you prepare the people mind to understand, receive what you are going to talk in the session. 2/3 of that period you prepare their mind, which means 40 minutes I have to prepare their mind to receive what I am going to convey. In the rest 20 minutes. Then 20 minutes alone the content must be delivered. Then it is a good communication. Nothing will be missed by anybody. Okay, so that is a mechanism behind the communication. And of course, sorry, I got into the other one. It is a not crude analogy, it is a required analogy. Coming back to machine algorithm, this is iterative process. It goes this way. That's a basic concept of your machine learning. Supervised, unsupervised, semi-supervised reinforcement. But another one comes to my mind. Sir, we have so many mathematical subjects, classical mathematics. Up to 4th year in some universities, they had mathematics, then Board of Studies not allowed. Now they have up to 3rd year. In some places, up to 5th semester somewhere. It varies from university to university. So many confusions because of so many BOS. So now mathematics is there. Classical math. So can't we use the classical mathematics to solve this kind of challenges? Why we need machine learning? How do we differentiate, or what special with the machine learning? What is wrong with the classical mathematics or applied mathematics rather? Any questions from anybody or any answers from anybody for this question? Can't we use classical or applied mathematics to solve this kind of above set challenges? Should we need some unique method or other than the applied mathematics or classical mathematics? Anybody can answer this question? If you answer correctly, definitely I will reward. There is a concept, no? In the supervised learning, there is a, I mean, machine learning, there is a concept that one algorithm is there. Reward algorithm, award algorithm, punishment algorithm is also there. Reward and punishment, reinforcement, something like that. You definitely, you will not get any punishment. You will get appreciation if you put forth your view on this. The question is, applied mathematics or classical mathematics are there. So many things are there. Can't we use those methods to solve the challenges of WSM? Why do we need yet another a unique method, so-called machine learning or artificial intelligence? This is the question I am asking. If anyone knows the answer, please come forward. Definitely, I will reward. If the answer is correct. Yes? Okay, no problem. I take this way, I deem it this way. You know the answer, but you wanted to have my dimension. With that understanding, I proceed. I don't have any slide to narrate the differences, but there are many differences. Main difference, if you take classical, let me take pen if possible. If you take classical, suppose as I shown in the machine physical system, no, physical system is there. A physical system is there. I say that this is the physical mathematical model of some physical system. Okay. V is directly proportional to I, then proportional constant is being proportionality is being replaced by the proportional constant R, then this becomes V is equal to IR. This is the mathematical model of some physical system, Ohm's law. Something like I can write. So when I talk about this equation or the standard other linear equation, line equation, if you take mx plus, that is x, sorry for my poor handwriting, this is x, mx plus c, this is line equation, linear equation. If you take, there are these are all the classical applied things, no? There are some entities required, variables. X is one variable, y is another variable, v is variable, I is variable. That variable you can classify into two: independent variables and dependent variable. So you know very well that x is independent variable. Independent variable is the variable which is defining the domain itself. Put it otherwise, still clearly, when I take the frequency response of any amplifier or any filter, I used to plot the frequency value along the x-axis. Frequency response, frequency domain. Frequency is going to be the x-axis, that is the independent variable. And the y-axis, what I am going to put? The magnitude, the output response, maybe the voltage, maybe the current, maybe the power, something depending upon, maybe the phase also. On the other side, if you analyze the system with respect to time domain, you put time in the x-axis, that becomes independent variable. You can take anything on the y-axis. Here, x is independent variable. That's what it is, a variable governed by the domain. Domain in the sense, not only time domain, frequency domain, the application which you have taken, and accordingly the domain variable. And y is the variable, so-called dependent variable, that is a variable to which you have to identify the value. That is what your metrics, that is what your measure of the system. For example, I want to measure the communication system. What is the measure with which I can able to quantify the communication itself, peer-to-peer communication? Bit error rate, it is a measure. It is a metric to understand the quality of the communication, quality of the reception. That bit rate comes always in the y-axis. SNR comes always in the x-axis. SNR is independent variable. That is a variable. It is going to govern by the domain. This is a variable to which I am going to explore the value. Bit rate. What is that for this? So that is what the classical method. Variables are required, and you need some equation. This is equation. This is another equation. Give the initial condition, solve it, and do it. That's all. Classical method. But when you take ML, classical method, it goes this way. When you take ML, you look at ML doesn't need any input. Please remember here, you have to give input. If I say this is a system, you give input and you take the output. And you can talk about the transfer function, efficiency, gain, so many things. Control system, you can remember all terminology. But here, there is no such input is fed into the system. Is it input? Is it input? I can say it is not input data. That's all. This is not the input like this. I cannot say this is something like X value, Y value. This is please remember here. I can. This is my understanding. My understanding. You can have a difference, no problem. But I am ready for discussion. Here, machine learning, there is no such kind of behavior. Data is the, I can say learning here, main concept is learning is the key. This is the key. KEY, I am writing KEY. Sorry, pen I should have taken. Okay, pen only. Okay, KEY. This is the key. Learning is the key in the case of machine learning. There is no input output. You have input port, output port. What you are giving is the data you are giving, not to transform that into output. You are making data, or you are giving data to the system to make the system to learn. Learning is the key. Such things are not there. That is why this is escalating itself into intelligence. You give data, it learns. If it is not learning, you change the data. You give some other data. If I say ball, red color ball, child may not understand. You bring the red color ball and say, this is what red color ball. Then that fellow will understand a little bit more than what it was told. So change the mode of data. Learning is the key in the case of machine learning. That is the major difference. Please, this you might be knowing, but in a continuum, I am telling this. Classical or applied mathematics, it is not. Learning is not there. Equation is there. You give this input. This is the input. As per the expression, I add this, I multiply this, and result this as y. That's all. Don't ask what is what. But here, you give data, then you give other one. I can able to classify. I could able to map. Here also input to output mapping is there, but the input, what I say like this, it is not there. 1-to-1 is not there. That is the beauty of your machine learning. That makes the machine learning edge over the applied mathematics or classical mathematics in terms of application to this kind of domain like WSN or other communication arena. Moving further, supervised learning. This is a class. This class is one of the principal approaches to processing data in machine learning. In this
yes,
approach,
sir,
in this approach,
agreed. Yes, sir. Sorry for interruption, sir. Yes, sir. So from the question you have asked and the explanation you have given, sir, So I understand that classical mathematics it is used to provide the foundation for core functionalities in a wireless sensor network, whereas ML and AI they can be used for handling complex data and making intelligent decisions.
Yes, absolutely.
Sir, right, sir. Okay, thank
Absolutely.
you so much, sir.
We can model anything. We can model as a mathematical model by using the classical or applied mathematics. But you can give uh, some kind of more than that to the system by imbibing this kind of machine learning methodology. That is what I understand from the literature. Yeah, exactly.
Correct, sir. Agreed. Yes, sir.
You have taken an abstract of what I told. Yes,
Sure,
absolutely correct. Yes.
Thank you, sir.
Thank you. So in this approach, we supply input as well as output. You see where we will supply output. We supply input as well as output labeled data sets. That's what the beauty of machine learning. We give input, output. What is that we are looking is the relation between these two. Relation between these two. Input itself is your output in the machine learning. But you have to recognize whether that is output of that or not. That knowledge you are, that's what the learning mechanism. But here in the machine, I mean, applied mathematics, it is not so. That is a different, that is a classical. I am not underestimating. It has its own application. It has its own requirement. Here it is a different. The nature is that. That's why I said in one of the slides, evolution is the instinct of the nature that nobody can deny, nobody can stop. During the system training phase, the relationship between them is discovered. Yes, it is in the function of, say, I can say y function x tends to y. When after the training, we can identify a function f such that for input x, it can produce the best estimation of output. Output is given, input is given, you have to put that. Essentially, generating the model that represents the dependency relations between features that, please note down, features of the system. And predicting outputs represents a central task that is a supervised learning algorithm. So label, normally say data with the label is called supervised learning, but the inner meaning, the nuances inside that is the relation between them is being done through the learning mechanism. Of course, all are learning mechanism, but slightly in the case of unsupervised or reinforcement, the logic is different. Within the supervised, we have regression and classification, classifier. That is again another subtopics. We will discuss that also. Am I clear to all?
Yes, sir.
Okay, thank you,
Sir.
thank you. And for the surprise, supervised learning solves different issues in wireless sensor networks, including this by these authors, starting from 2007 to 2023. I said no, that paper. They anomaly and fault detection, coverage issues, localization, routing, MAC, congestion control, synchronization, aggregation, harvesting energy, even beautifully they did. But I have not gone through all. I went through 3 papers out of these 11. Interesting. This supervised learning is partitioned into regression and classification, as I mentioned. Under the classification, you have perceptron-based algorithm. There are 3 headings: logic-based algorithm, artificial, deep learning. Under the logic, decision tree, random forest, they come. And on bar with the perceptron, statistical learning algorithms are there, Bayesian, SVM. Instance-based algorithm is the KNN. All these things are coming under the supervised learning. And regression is another. Classification, what I can say, classifies binary or multi-class classifier. Binary classifier, either this or that, or multi-class classifier, it says that one of them. Many things are there. It could be able to classify this. Regression, it is not classifier. We are going to address that regression. It is an interesting area that I don't know. The terminology you would have heard many times, and you are using, or you have used very frequently, or I can say very frequently, yes, frequently, or in your career, either UG or PG, you should have used it. That's what my understanding. Let me see. Regression, it is not new. It is not new. Concept is not new. You would have heard and you would have used the concept earlier in your career. Let us take regression first. And before that, what is the supervised learning? I told this is machine learning, no? So what is supervised learning? Am I audible? There is a power trip from my side. I wanted to ensure. Enamal, am I audible?
Yes, sir, you are audible, sir.
Okay, thank you. Supervised learning, the label is there. Label is there. I give the label to the input. This is a system model, ML model, so-called a supervised model. I train, this is this label, this is this label, this is this label. Then I give another without this data. This fellow says that this is this. Then accuracy is there. This is called a supervised learning. Very simple. Regression. I said regression is one type of supervised learning. Method of supervised learning which predicts the value y based on given set of features. X is not input, features. Within a regression model, variables are either quantitative or continuous. The quantitative, it could be discrete or continuous. Regression represents a really simple approach of ML predicting outcomes with a small margin of error. There is an error, but prediction is going to be always good. What is it prediction? Having given the feature as input, you are going to determine the output for the features. There is a very, I narrate something and from the features you are going to tell the object. That's what. 2 legs are there, 2 hands are there, 1 head is there. Who is he? Who is, what is that? You can easily say that is a human. Something like that. In mathematically, you can say y is equal to f of x plus epsilon. Try to understand the variables, I mean the parameters. Y denotes the output, which is a dependent variable. X denotes the input, which is an independent variable. F represents function that determines the relationship between y and x. Epsilon is random error, possible random error. This is the regression, very simple regression. So many variants are there: linear regression, non-linear regression, etc. In simple, we will see what is what. Regression is applied to resolve different issues in WSN, including data aggregation, connectivity issues, energy harvesting, and finally localization. Out of 71 papers, these 4 areas alone covered. I told him more than 12 challenges. I witnessed more than 12 challenges in WSN. Out of 12 challenges listed in the paper, only 4 challenges are covered by this regression. Of course, how many paper I will show you. I take a regression, a simple linear regression schematic representation. This is coming here. Features we extract. I said X denotes the input, which is an independent variable. You give the feature, set of features, no? We extract feature from the data and give as input to this model. And this algorithm is learning that, and out of that, this model is going to finally give what is y. That is what the model is. And we refer this also, training y also. Quality check, quality metric. If this is y, what I get y is correct, yes, tick. Okay. Now, this, as I said earlier, regression is not a new concept. We have been using in this subject, digital communication. This is a schematic representation of the digital communication. I'm not going to tell all this block. I'm going to take only this area, particularly this alone. Just for continuum, I have put, and a couple of other slides are going to be very not in order with the other slides. You have to, I regret, but you have to forgive me for that, or sorry for these improper slides. Okay. What is that I do is that this is, if I account the AWGN alone, I can say this is the channel, and this SM of T is the transmitted signal received. Transmitted signal given to the input, received is this. And the received signal can be modeled accounting only AWGN noise, SM of T plus N of T. Of course, noise is added in the channel. This is what AWGN model. Okay, fine. When you proceed, when you want to estimate, or when you please remember from this only you have to estimate the signal, and you have to predict whether transmitted is 1 or 0. Whether the predicted is correct or not, we take the decision, and accordingly bit error rate, accordingly the quality of reception and the performance of the communication relies. Isn't it? In the process, you are going to predict, estimate. And what is that you are going to estimate? You are going to estimate X of T. Since you are going to estimate, it becomes X cap. X of T you are going to. There are this kind of concept you would have studied. The process of estimation, minimum mean square error, minimum mean absolute error, MMAE. Maximum a posterior probability, MAP, maximum likelihood decoding process, ML, something like you would have studied in the process of that. What they are, what is the likelihood? What I received must be more close to what was transmitted. What I received is this X cap plus noise. I filter it out somehow, and I explore R of T from this, and R of T is estimated. R cap of T, you take that R cap of, from the R cap of T, I wanted to take a decision based on the estimation. Decision I want to take. Likelihood means what I estimated likely to be what was transmitted. Then it is nothing but maximum likelihood. It is the maximum likelihood is the probability. Basically, it is a probability. What is the probability of what I received would be what I transmitted? That's what. That must be maximum. If it is 1, correct decision. If it is 0, wrong decision. Of course, threshold we are going to put based on so many factors. That itself is a big job. Okay, that we assume that it is done. Threshold is done, and based on the threshold decision, of course, noise is added to the signal. Therefore, the noise, signal received magnitude will fluctuate. Therefore, estimation. Therefore, you know. So the point is, these things, maximum likelihood is possible provided if you understand and if you assume probability of the same symbol what we transmitted is EQ probable. If you transmit EQ probable, then the maximum likelihood is possible. Otherwise, the maximum likelihood fails. That is another condition. And these things we can transform into least square method, LS, another algorithm. Please remember, all these things are variants of regression algorithm. All these things are variation of regression algorithm. That is what you see, that the same thing, is it not this equation? Y is equal to f of x plus this. Here, if you look at, this is not alone this, you are going to multiply with the H matrix, channel matrix, no? That is what the function. And this is not alone. This you are going to add some other things, ISI, and I took only this noise alone. And in the process, this is another version. You know, some variation of your regression. What we discussed in the previous slide. And these things are the standard algorithm which we have studied, which we are studying now also. LS is another maximum. We now say least square method. When it comes to the error must be as low as possible. The quantity, when we look probability, likelihood must be maximum, error must be minimum. Both are same. I can easily transform this into least square problem. The same problem which is attacked with maximum likelihood probability, or using that can be transformed into least square problem by introducing only one. That is what your base concept, the probability concept, that I will tell in the next slide. Before that, when I go for this kind of regression, what is that expectation of this is taken. Expectation of this all are estimation with, of course, the error. Okay, noise. If you take this, can be expanded to these three: bias, variance, and the noise. This is the variance formula. The beauty is, if you want to maximize the likelihood or minimize the error, what is possible is that you have to do something here. You have to do something here. Out of the three terms, you can play around bias and variance. These two things can be maneuvered. The third term, this noise, is not in our control. You cannot control that third entity. You leave it. We stuck with this. We got stuck with this. These two things we can vary. Interestingly, these two things, if I increase the bias, variance is coming down. If I increase the variance, bias is coming down, inversely proportional. So now the challenge is the trade-off. Challenge is the trade-off. Please remember, your classical method, applied mathematics, can give up to some extent solution for this kind of trade-off. Whereas if you take ML, this is based on the ML, based on the supervised learning method. The learning method, what it does is that it observes. It observes. Carefully, it observes between these two entities, bias and variance. It observes. And for what set of bias values and variance set, I am telling set, bias and variance set, this fellow is minimum. And what application that is minimum is recommending the learning method. Whereas your classical method, what it does is that mechanically it does. Whether you give this or that, it grinds. That's all. It is not understanding what you given mixie. You put a coconut, you put any other things, you put a piece of metal, it grinds. That's all. It is not understanding. It is not edible. We should not grind. I should not grind. It is not understanding. But whereas your learning methods, what it does is that what set of this and this, these are inversely proportional. Okay. In fact, if you ask what is a bias, something like a bias, you can define how far away the trained model is from the correct one. Trained model, correct model is there, no? How far away the trained model from the correct model? That is what the bias. And variance, it talks about the magnitude of the bias. Very simple sense. The difference between the correct and the trained data. This is the magnitude of the bias. These two things are inversely proportional. And if you give learning method to the system or the algorithm which could able to learn this and update itself and take a decision by itself, that is expert. It becomes expert. That is what it is. Finally, our objective is to reduce this error. This error is not controlled by this. It is controllable, but it is not menued. We can menu these two things. Your classical applied mathematics can give up to some extent, but not beyond that. Limitation is there, but this can go beyond that. I'm not telling this is the only method. This is a better method than those. It can provide better. I think I communicated to you clearly. And the bias and variance, how it can vary is being shown here. I will share this. You can go through that later. This is the concept I said, no, the maximum likelihood you can transform into some other form with the help of your probability. The Bayes theorem is the theorem with which you can, it is given nicely through some example analysis, and this is the basic model, and this can be written this way also. You see that the other way of writing the Bayes theorem. Okay. I don't know how to, now only I'm going to start the classical method, classification method, first method. Can I help? I mean, can I take help from others? What way I should plan? Because 4 o'clock is my time. I don't want to waste your time. Can I, what is schedule? Should I stick over the schedule or can I spill over? I will stop by 4. Is it okay?
Okay, sir.
Yes, sir.
Okay, sir.
Oh, okay. Then if that is the case, accordingly, I have to go around. Decision tree is the first algorithm of ML algorithm under the classification. This is using if-then set of rules. And in the case of WSN, data aggregation, anomaly detection, connectivity, selection of mobile. These challenges are addressed by this algorithm under this for this application. The other things I skip. Wherever it is possible to highlight, I can highlight according to the time factor. And this is the decision tree. As I mentioned here, decision is one branch of the tree. This branch can have choice. Leaf that is not having choice, it is the final result. You can see that decision, two branches. Decision has branch as a decision and decision. When it comes to decision, it has a branch leaf. It can be leaf or decision. If it is leaf, this is the end. If it is a decision, it can have subsequent offspring. That is what it is. Okay. And the other one is random forest algorithm. This is again developed based on the decision tree. Here decision is based on the one attribute. If I take a multiple attribute, then it becomes a random forest algorithm evolved from the DT algorithm. And this this algorithm is used to address the challenges like security. Somebody was asking security. Security, you can think about this algorithm, and anomaly detection. Both are coming under the security. In the case of WSN, it is working relatively better. Here, when we use this kind of algorithm, overfitting is a problem that we must be careful. What is overfitting? I just added one slide to understand. This is underfitting, this is good fit, this is overfitting. Overfitting, I can say, if you know, no problem. Otherwise, you can understand 9 dimension of understanding also. That may still make you to clarify this concept a better way. During the training period, it is giving a very good performance. It understands all. But when it comes to the test, it is not doing. Best example, one crude example I take. There are 2 students in a class. I take 2 students. One student for the examination or test studied only 5 questions. Another student studied 5 units. All units he studied. Test over. 5 questions studied student scored 100 mark. 5 units studied, all studied students score only 70 mark. Okay. The first student studied 5 questions. Second student studied 5 units. First student scored 100 mark. Second scored 70 mark. The beauty is that the question paper, all 5 questions, none other than what the first student studied. Therefore, he could able to score 100. Second person, he knows the concept, therefore he managed all and he scored it 70. Now the question to you is, who is knowledgeable in a particular subject? 100%, 80, 70%. Normally, more person we deem it, he is knowledgeable. But in this case, we know pretty well the first student is not having knowledge because he chosen only 5 questions. Unfortunately or fortunately, only those 5 questions have come as a question paper. Therefore, he could able to score 100. This is what overfitting. The other one is normal fitting, good fit. All studied 70, he scored. The understandability of the person in a subject is 70%. That is what it is. Put it in general, this learning method, in irrespective of whether regression or classifier or other type of unsupervised, any method holding good, don't look whether my algorithm is working perfectly or not. Don't look at how perfect it is. Don't look at, you look at how well this is working. That is what it is required. My algorithm is working well or not well. That comes under the, or it is parallel to the second student performance. Perfect is parallel to the first student performance. He selectively, and that is what overfitting is resulting, because you train only that data and that algorithm, like a student, he memorizes and answers the output. Yeah, this is that, that is this. He is not learning, he is memorizing and answering. What we need is, learning is required. You see, sometimes machine also imitate the human psychology, no? That's the beauty. Then artificial neural network, you know, input layer, output layer, and there are n number of hidden layers that depends upon the application. And this is mimicking the, what I can say, the human neuron model. This is the model: input layer, output layer, hidden layers. Of course, interconnection of neuron, almost that is what happening almost all layer. Output layer, you are bumping with the activation function. That is the beauty of this neural model. And deep learning is a subclass of artificial neural networks. Practically, this processing as well as the communication patterns in the nerve system of human represent the principal source of inspiration for this. The nervous system of human is mimicking that kind of things. That's a beauty. And if you go for SVM, again, type of support, I mean classifier. It is also a classifier. It is based on the hyperplane. What do you mean by that? This is something like this. This is one category classifier. No, the boundary line is required. Boundary line is very, very, decision boundary is very, very crucial and critical. How do I make here? Can I make a boundary here? It is not separating this yellow color with the blue color. No, this is the boundary it could able to separate. If I put here, this is getting affected. If I put here, this is getting affected. So I can take, this is the extreme entity of this group. This is extreme entity of this group from this side. Okay, I can take, this is the vector, this is vector, support vector to take decision. I take moderately in the middle of this. So whatever lies here is this feature 1. Whatever lies is here above this is feature 2. So these two things are enough to take the decision. And this is called basically the support vector mission, SVM. The beauty is that these two entities are enough to classify the features. How many data is there beyond that is immaterial. The size of the data is not at all playing a role in taking the decision, whereas it is not holding good for the other algorithms. This is the one of that such algorithm. The data size is immaterial. Whether it is a small data or large data, it doesn't mean that. These vectors positions are important, and thus what way we are going to take the decision boundary is very important. It comes. So naive Bayes, it performs better. That's what I understand. Table I will show you. I just rush through that. K nearest neighbor, KNN is another classifier. You see that double plus is very high. NB is naive based. This performance is relative for all these attributes: response time, learning speed, complexity, all relatively better based on the survey. And this is second type is unsupervised learning. Under the unsupervised learning, you have two broad categories: clustering and dimensionality reduction. Each has three. All the things are there. Accounting the time, I just pause. K means algorithm. Grouping unlabeled instances to n distinct clusters. This is a logic. Convergence is possible. If it is not converging, you iterate it. This is FCM. Otherwise, you can call fuzzy Z means clustering. In WSN to address mobile sync, connectivity, localization, hierarchical clustering. Okay. Again, if I compare, probably this fellow K means this is working relatively better for this kind of set. And the unsupervised one among these three, K means hierarchical FCM. I said the dimensional reduction is there. Exactly, dimensionality reduction, it doesn't mean that we leave some of the features. To give some understanding, this is the three-dimensional representation of the cylinder. I can see as a circle. When I reduce the dimensionality through the above set algorithm, I look at in the 2-dimension something like this. Or I can take the plane instead of XY plane. If I take YZ plane, I look at this cylinder as this line. This is one feature. This is another feature. The cylindrical geometry is another feature of the cylindrical. So different features. When I transform the one-to-one, it doesn't mean that I alter the geometry. I reduce the feature required to represent the geometry. And if I look at the things in a different plane, I have different perspective, features, circle, line. By reducing the dimensionality, I say that I am not removing the feature. I mean, I am not altering the characteristics of the geometry or characteristics of the entity. I reduce the feature. I need only two entities here, circle. Again, two entities to draw the line, but with the different plane, X, Y, Z plane, XY plane. That is what the meaning of dimensionality reduction. And I go to the PCA, you would have used it. These are all the things addressed by using PCA for the WSN in this review. And SVD, SVM we have seen. Support vector mission. This is singular value decomposition. Again, this is not new. We have been using in digital communication. And one of my scholar, Professor Enamal, must be knowing. Supraja Eduru work is purely based on SVD and decomposition. And of course, she also used regression regressively. And many new understanding we got out of this. SVD also she used. Independent component analysis, another decomposition. Okay, semi-supervised learning, a blend of both supervised and unsupervised. We cluster the unlabeled one and we give labeling for the cluster. and cluster will labeled will be addressed by the supervised learning. That is the concept here, and it goes. Evolutionary computation is something like your nature inspired, that I put swarm optimization, no? Swarm algorithm. Under that, whatever comes in the WSN, these are also used for all. Okay, this is the schematic of understanding the evolutionary thing. If offspring is not acceptable, you terminate, don't accept into the population, and you iterate. It is iterative process. That is what basically. Reinforcement is the thing which I told earlier. It has some agent. Agent is helping to understand the concept from the environment by giving some kind of reward, award, punishment. All these things are possible. Positive, negative, something like that. From that, the neural network understands. It becomes expert system. Reinforcement, something like reinforcement. RCC in civil, you would have heard, the same concept. Reinforcement, cement curing, same thing. And with that, the methods are over. I wanted to see the impact of machine learning based algorithms on WN. You read this: accuracy is efficiency, improved efficiency is 40%, improved network lifetime is this much, accuracy is this much, complexity reduced is this much, and other factor, maybe your energy and life or aggregation, other things are coming around that. Sizable improvement people could able to make out of this ML based algorithm. And apart from that, emerging technologies are also there. IoT is there. You can club AI with IoT, then it becomes AIoT. Cloud computing, big data, cognitive computing, all the things. These are all the avenues you can expand WSN potential by combining WSN with these emerging technologies through the AI. Without AI, you cannot. That is also very thing. This is IoT architecture given, of course, 5 layers, 4 stages and 5 layers of YSI model it possesses. Sorry, WSN possesses 5 layers. This is 4 layers, 4 stages of IoT. How you can integrate with cloud, the WSN is schematically given. Just I go. These are all the 6G, as I told. Again, here also you have possibility, very good possibility, opportunity for exploiting AL/ML network. Your network itself is going to be AI-based network, ML-based network. This is one of the key enabling technology for next mobile communication, 6G, based on the key site. I also referred this in the reference. You would have seen it. And new spectrum, new NR and other high frequency, we are trying to terahertz, all we are exploring. That is another enabling technology. Digital twins, sibling, twins, sister, brother, something. Digital twins is also possible. Virtually you can have what you are getting in the real, you can get the same, the virtual also. That's what. Then the other fourth one is the new network architecture. That's enabling, another enabling key towards the next generation network. But the point is that this is going to play a major role. Therefore, I put this under the under this emerging technologies, 6G. And the challenges, put it otherwise in a layman sense, demerits. Demerits of WSN related to the use of AI. Yes, the other side of the coin also, AI has security, privacy. Someone was asking, security and privacy. Yes, it should be addressed. It should be addressed. We have to explore jointly. New routing cost, communication cost, energy consumption, knowledge management, interoperability. All these things are the issues. Challenges are to be addressed. We started. So many releases are there. So many avenues I have shown. These are all the points. Yes, very, very attractive points. Yes, AI, ML are given due importance in the emerging technologies. Therefore, these technologies are going to be enabling technologies to improve the performance of the new networks, new topologies, new use cases, new. What is that we need? We have to develop the ecosystem towards that. So AI and ML is the promising entity to develop required ecosystem. And to conclude, we have seen the need for AI in WSN, different algorithms of ML and AI, impact of AI in WSN, emerging technologies to be used with AI in WSN, challenges in WSN related to the ASI. And one more thing, just for my consequences of this is also very important. I put under the conclusion, next to the conclusion, under the conclusion, new phase of the technology we have to understand. Behavioral and cultural catastrophic is also parallelly happening. So what I am trying to convey is that, sorry for the animation, and I didn't know that it will take this much time. The same thing I have put, the new phase, you please understand phase of the technology, intelligent mission, all these things are through the evolution, that is instinct of your nature, and you get sustainable mission with intelligence. But later, if you look at it, that becomes not the girl. It is not woman or girl. It is humanoid. Humanoid. Thanks to all these technologies. Thanks to all this technology. But what is that we are going to face? Please try to understand the consequences. What is the consequences we get? Are we going to get the one side of the coin? Please note down. I don't have time to discuss the consequences. I leave it to you. You can imagine. The other one, behavioral and cultural catastrophic. You look at this kind of behavior. Quantity only we need. Wherever you go, entire world I want to swallow, if possible. Yes, everybody is looking at that. What about the quality? What about the trust? What about the other relations which we have? What about the love? What about the affinity? All are question mark, exclamatory. Where is the solution for this? Your mentor will provide solution. Your family, system, country, world? No. Solution is not from this. Then from where? One has to have a new dimension of view, not the different horizon. You have to have a new dimension. What is that new dimension? The solution is within you. Introvert, you look into you. Look into you. Then if you look into you, the no can be tilted on. Your journey on. No becomes on. You can look at no the other way. What is needed is 180-degree phase shift. Not system phase shifter in your thought you have to have. And that is going to be the solution for the above said problem. Please remember, when we address this kind of technologies with the new methods, new technologies or new other techniques, that's the other side of the coin that we have to be careful. And to mitigate that kind of things, this is introvert is always required. To do the introvert, nobody is required except you. You have to have your own control. If you do that, no can be made as an onset. On, it is a very beautiful word. So with this, I would like to conclude. Of course, these are all the acronyms used, and these are all the references, and other things are there. Let me conclude by telling thank you, slide to you. Thanks to all the people. I leave the final, of course, you can read. Thank you very much. I take this opportunity to thank, first of all, the organizers and equally the attendees, participants, various faculty members, different faculty members from various institutions. Thank you very much for your time, sparing your time and understanding my concept, whatever I shared over this period. Special thanks to, again, Professor Enamal for giving me this opportunity. Thank you very much. If time permits and if you have any clarification to make from me or argument with me, I am ready. Now the thing is open to forum.
Thank you, sir. Thank you for your wonderful session. Participants, do you have any queries so that the sir can clarify? Any queries from the participants?
Sorry, I could not concentrate or elaborate the concepts which I listed. I thought of doing it. Accounting the time constraint, I could not elaborate. And it is true also, one cannot complete all within the very short span of time. That also I understand. But I appreciate your cooperation for listening my difficulties. Okay. Any queries?
No problem, sir. We have understood very well. Thank you so much, sir.
Okay, thank you. Okay, thank you for the opportunity.
Thank you, sir. Thank you, sir.
All the best for participants and organizers for other sessions.
Thank you, sir.
Thank you. I can leave. No, Can we take one photo at least? I can request all the participants, those who are available, to switch on their camera, if possible. We can take one snapshot.
Please make on your camera so that you can take a snapshot.
Those who are interested, we are not forcing, it is optional.
You can take a screenshot.
Yes, sir. Yes, sir. Thank you, sir. Thank you very much for your wonderful session.
Thank you very much. Thank you, HOD sir, for giving this opportunity to me and discussing the. Very good. Thank you.
Sir,
Thank you,
Ravi Kumar and
participants.
Amar both are also available here, sir. They also joined.
Okay. Thank you. Thank you, Amar and Ravi Kumar Kota. We will meet
Sir,
in some other
thank you,
time.
sir.
Thank you.
Sir, okay, sir. Thank you, sir.
Bye. Okay.
Okay, thank you, sir. Dear participants, please complete that feedback form so that we can end the meeting.